So before we really get into describing domains for our functions, I want to do some review of notation. Now, we did use interval notation last year in Algebra 1, but again, I want to review it. And we're going to tie in that inequality notation that we have as well. I want to practice both because you will see both. If I don't specify in the directions, give me the domain in interval notation or in inequality notation. If I don't say what notation to use, you can use whichever you like better. But you can expect to see both versions in questions that I ask you, which is why I want to make sure that we practice both. So kind of back to that number line idea that we talked about from elementary school. I am telling you, we are looking at x values over the interval from 4 to 7. Now, for domain, we are only talking about x values, okay? Just x. So these are x values. Interval notation is the x value where this thing starts, comma, the x value where this thing stops. Okay? Just x values in an interval. In Algebra 1 last year, we also talked about increasing and decreasing intervals, positive and negative intervals, and they're all defined by the x values. We actually just talked about increasing, decreasing, positive, negative, domain, and range in Algebra 1. And one of the things that kind of helped us keep in mind that we're looking at x values was we talked about when you watch a video, right? You watch a video like on your phone or something, it's got that little bar at the bottom, right? I feel like it's always red for some reason. But it's got that little bar at the bottom that shows you like your time progress through the video. So I want you to think about giving me the timestamps, right? That little bar at the bottom for your video is horizontal, just like the x-axis is horizontal. So you were giving me, like if I were gonna tell you, hey, watch this video, but like you can skip the first minute, just watch from like minute 1 to minute 2. Like that's the part that we care about, or maybe that's the part that's funny. I'm giving you timestamps, right? I'm giving you an interval. So it's the same idea here. Think about it like timestamps if you need to on a video, okay? So that we remember we're just looking at x values. Now for our warm-up problems, we only have x values as an option. There's no y-axis here because we're on a number line. So I'm looking at from 4 to 7, okay? In inequality notation, this would be x values between 4 and 7. So we would put our x between 4 and between 7. Now, I know that my inequality signs would be 4 is less than x is less than 7. But the sort of tricky thing that I need to determine is, are these just less than or are any of them equal to? So I'm going to look back at my interval. I've got a parenthesis at 4 and a parenthesis at 7. If we look at the next example, we have, instead of a parenthesis, I've got a bracket at 5. A bracket is an or equal to. Just a parenthesis is strictly less than or strictly greater than. So that means on my graph, these would be open circles. So at positive 4, I'd have an open circle. At positive 7, I'd have an open circle. And then I'm looking at all values between 4 and 7. So I would shade between those two values. For our second example, we're looking at 5 to infinity. So when x is 5, since I have a bracket at 5, that means I would put, oh, you're right. That should not be negative 4. It should be positive 4. Good catch. Should be positive 4. So none of this either. Yeah. For our second example, at 5, since I have a bracket, I'm going to fill this circle in. And then this is until infinity. So that means for the whole rest of my number line, all of those values are included forever. There are actually two ways I could represent this in inequality notation. So 5 is less than or equal to x. Since it was a bracket, that's an or equal to, is less than infinity. Or we could just say x is greater than or equal to 5. That's what this means here. All values greater than or equal to 5. So all of these mean the same thing. For our next example, we're starting with inequality notation. So I'm going to start with my number line graph. So from -10, and that's going to be a filled in circle because we're equal to 4, which would be an open circle because we're not equal to. I'm looking at all x values in between. X is greater than or equal to -10, but less than 4. Everything in between those 2 points. In interval notation, we're looking at the x value where we start and the x value where we stop. Remember, we always read a graph left to right, like words on a page. So where I start is at -10. Where I stop is at 4. Since we have a filled in or a closed circle at -10, -10 would be a bracket. At 4, we have an open circle, so that would be a parenthesis. When you are writing interval notation, please make sure you are careful about parentheses versus brackets, and please make sure I can tell the difference. For our next example, x values that are greater than or equal to 0. So I'm going to go to 0. What kind of circle am I going to put? What kind of circle will we put at 0? A closed one, because we're equal to. And then I want all x values greater than, so I'm shading everything greater than 0, all the numbers bigger than 0. Interval notation, we start at 0. And then where do I stop here? Yeah, we're going forever, right? We don't ever have an end point, so that would be to infinity. Bracket or parenthesis at 0. That would be a bracket because we include 0. And then here's the tricky one, bracket or parenthesis at infinity. Always a parenthesis at infinity, okay? Brackets are for places where I could look at my graph and identify that closed circle. Is infinity going to be a place I can put my finger on a number line? No. Remember, infinity is an idea. It's not an actual value. Okay? For our next example, I've got sort of a split here. I've got 2 separate pieces we're going to talk about. This kind of weird looking, boxy looking U in the middle is the symbol for union. It means this part and also this part. So my first section is -infinity up to -1. Since I have a bracket there, I will have a closed circle at -1. So at -1, I would have a closed circle. And then to -infinity is where I start. So I'd be all the way back here, all the way up to 1. And then for my second piece, 5 to infinity. Notice it's a parenthesis next to 5. So at 5, we would have an open circle and then everything bigger. In interval notation, this first piece would look like x is less than or equal to -1. My second piece would look like x is greater than 5. It's an open circle, so strictly greater than. Now we see some inequality notation that tells us we're looking at 2 separate pieces here. It's very faint, but there is a line underneath that inequality sign with 3. So if I were to graph this, x is less than or equal to 3. I'm going to go to +3 and put a filled in circle. And then I'm going to shade everything less than 3. My other piece is x values that are greater than 7. So I'm going to go to 7, and it's an open circle because this is just greater than, and I will shade everything greater than 7. Since I have 2 distinct pieces here, that means I'm going to write 2 sections for my interval. I'm going to write 2 intervals. My first interval would start when x is negative infinity. All the way back forever in the negative x's would be negative infinity. That's where I start. And then I stop when x is 3. Parenthesis or bracket at 3? Bracket. And then union symbol. And then for my next section, I start at 7 and I go forever. So that would be infinity. Parenthesis or bracket at 7? Parenthesis. Open circle at 7, we're not equal to 7. And then always the parenthesis at infinity. Now on your papers here, it was where it copied, it was really difficult to tell where those shaded regions were. So for the last 3, you have the graphs. I darkened them on mine so it'd be easier for you guys to see where the shaded regions are. I would like you please to give me interval and inequality notation for those last 3. You have the graph, give me the notation. Anybody remember doing this in Alg2? We used I don't think they were exactly the same examples, but we used a very similar format. For example, we talked about the new and interval. Very good. Okay, let's talk about these. Make sure you check what you've written as we go through them. So of the last 3, for my first problem where I have the graph given to me, we are looking at x values that are between -7 and 10. So we start at -7, we stop at 10. I'm going to put a bracket at -7 because that is a closed or filled in circle. And the same at 10. 10 gets a bracket as well for the same reason. It's a filled in circle. In inequality notation, this would look like -7 is less than or equal to x is less than or equal to 10. Since they are filled in circles, these are or equal to. For my next one, we're in 2 sections here. It's not one piece together. We're in 2 sections. So I'll have 2 intervals that I write. I'll have 2 inequalities that I write. For my first piece of my graph here, we're going all the way back this way. So that means our starting place would be negative infinity. And then we go up to -2. Always a parenthesis and infinity. And then do I want a parenthesis or a bracket at -2? I want a bracket. It's a filled in circle, so that's a bracket. Then I'm going to use my little notation here, my union symbol, and I'm going to write my other piece. So for my second piece, we start at 10, and then I'm shading the rest of the graph. I don't have another stopping point. I don't have another end point. So that means I'm going to infinity. Parenthesis or bracket at 10. Do I want a parenthesis or a bracket at 10? That's a bracket at 10. It's a filled in circle. That's a bracket. How about infinity? Always a parenthesis at infinity. In inequality notation for this first piece, there are two ways that we could represent this. And we kind of talked about that idea up here with our second problem. But you could write this as, if you like this sort of format, small to big, negative infinity is less than x is less than or equal to -2. This would also be the same as just x is less than or equal to -2. So either of these could represent this interval, this shaded region of the graph. For the other section on our graph, we could write this as 10 is less than or equal to x is less than infinity, or just x is greater than or equal to 10. They mean the same thing. Up to infinity is implied here, down to negative infinity is implied here. And then our last one, interval notation. I'm going to have two pieces again. My first piece, since we're shading everything below -6, that means our interval would be -6 or negative infinity up to -6, up to -6. There we go. Always a parenthesis at infinity or negative infinity. How about at -6 for this one? Parenthesis or bracket? Parenthesis. And then for my other section here, we start at 7 and then continue forever. This would be 7 to infinity, parenthesis or bracket at 7. Open circle, parenthesis. And then always a parenthesis at infinity. In inequality notation, this would look like x is less than -6 or x is greater than 7. If you like the same format here, this guy could also be written as negative infinity is less than x is less than -6. And this guy would be 7 is less than x is less than infinity. So moving forward, if I don't specify notation, you can give me whichever notation you like best. But you do need to be familiar with both and understand what both are asking you for. So now that we've done some review of the notation, let's actually start talking about domain. Okay. Domain, again, are those x values. What input values can my function take? Okay. So for a couple of these, we're going to look at graphs similar to what we just seen in Algebra 1. So I've got a function graph here. We're looking at, again, where we start and where we stop. Just the x values. I do not care about the y values at all. I do not care about y. Just the x values. Domain is just the x. So we start when x is -6, and we stop when x is 11. So my domain from this function would be -6 to 11. Do I want a parenthesis or a bracket at -6? Parenthesis, it's an open circle, that's a parenthesis. How about at 11? Another parenthesis. In inequality notation, again, I'm going to practice both as we're working today. This would be -6 is less than x is less than 11. For my second example here, again, I do not care about y. Don't care about it. I only care about x values. My domain would be from -11 to +11. Parenthesis or bracket at -11. Parenthesis or bracket at +11. Bracket, it's a filled in circle at +11, so that'd be a bracket. In inequality notation, this would be -11 is less than x is less than or equal to +11. Moving to our bottom examples on page 2. I'm looking at a function that has this sort of like stopping point, right? I've got an arrow this way telling me you're going back forever. So any x value that's back here, back this way, is fair game. So if I'm talking about when does my x start, this would be negative infinity. And then when does it stop? That we can see on the graph. We stop here at 4. Now, as we start looking at talking about domain and range of functions, where our only focus is not domain and range. If I look at my earlier problems, I had like a big bolded point here at 11, right? With these big like dramatic points kind of marked for us so we could be extra sure of where that place was. I don't have a big bolded point here. So sometimes we get a little confused on if we're including that or not. Anywhere on a graph, on a curve, right? If it's not an open circle, that means it's a closed circle. So here, even though it's not a big bolded point, since it's not an open circle, it's a closed circle, okay? So that would be a closed circle at 4. So we'd be looking at negative infinity to 4, including 4. I want to bracket at 4. In inequality notation, you could have negative infinity is less than x is less than or equal to 4, or just x is less than or equal to 4. Those mean the same thing. For our last example here, your function is in 2 pieces again. I would like you to give me the domain for this function. So domain of this piece and domain of this piece. Okay, x values for this piece and x values for this piece. Give me the domain there. For our first piece, since our arrow goes forever this way, that means we're gonna keep taking x values that are farther and farther back to the left. So this would be negative infinity to negative 4. Parenthesis or bracket at negative 4. Bracket. It's not an open circle, it's a closed one. As an inequality, this would be x values less than or equal to negative 4. For my second piece, my smallest value would be 8. And then we continue forever, so that would go to infinity. Parenthesis or bracket at 8. Eight would be a bracket. As an inequality, this would be x is greater than or equal to 8. Questions for me so far? Okay, so we have focused just on domain here. For the next couple of examples, we're gonna start bringing back some of the things that we've seen before, some of the topics we've covered already. So we're gonna see some function notation, we're gonna talk about x and y intercepts, okay, tying in some of the stuff from our earlier units. So on page 3, we have a piecewise function here. Right? Here's a piece of it, here's another piece of it. And I want to evaluate for these given values. Remember function notation, if I've got a value inside parentheses, that's my x value. I'm asking you what's the y value for that point. So f of 4, so when x is 4, y is 6. F of 4 equals 6. F of negative 3 means when x is negative 3, on my graph, y is negative 1. F of negative 5, here's negative 5. Follow that to the point on my graph, and y is negative 3. And then finally, f of 3. Here's where x is 3, follow that to my graph, and I've got an open circle here, and then also an open circle here. I don't have a closed circle anywhere that x is 3. So what do you think that means here? What would I put? It would, well, they're both open. So it isn't either of them because they're both open circles. I don't have a closed circle anywhere at 3. Right idea of no solution, but what, since we're not solving, what I'm going to put is undefined. But right idea, undefined. I don't have a defined value, undefined. I don't have a defined function value when x is 3, so we're going to put undefined. So when I give the domain here, since we are not defined at 3, we don't have a function value when x is 3. When I write my interval for my domain, I'm going to have 2 pieces. Okay? I'm going to have a piece that represents this part. So when x is -5 up to +3, we're going to have a bracket at -5 since I have a closed point there, and a parenthesis at 3. And then my other piece picks up after 3. Right? I don't actually have a y when x is 3. It's undefined there. So we start at 3, and then my other piece goes until x is 6. And again, bracket there because it's a closed circle. So I have to write 2 pieces because I've got a value in the middle that doesn't have a point. What would be my x-intercept for this graph? -2 across the x-axis at -2. And then how about my y-intercept? +2 across the y-axis at +2. Very good. And we worked with piecewise functions before. We've evaluated off of piecewise functions, both from the graphs and from the functions themselves. We haven't yet written a piecewise function, so this last part is new. When I write a piecewise function, we're going to use each of these domains here to identify which piece I'm talking about, and then we'll write a function for those pieces. So for the sort of lower values in my domain, this is a line. It's got, it looks like a slope of 1 and a y-intercept of 2. So this would be the line 1x plus 2, or just x plus 2. And then when I tag the domain for a piecewise function, we use inequality notation. So this piece as an inequality would be -5 is less than or equal to x is less than 3. The other piece of my function is just the horizontal line y equals 6, right? I don't have a non-zero slope here. The slope is just 0. So y is 6. 6 there, and that matches the later part of my domain. So from 3 up to 6. So 3 is less than x is less than or equal to 6. For x values between 3 and 6. I would like you now to try the problem on the next page. It's a different graph, but the same idea. There's some evaluating, give me the domain, give me the x and y intercepts, and try to write that piecewise function. You try the problems on the next page now. Yeah. Alrighty, let's take a look at these. Most of us seem like we were doing just fine with the evaluate part, but then we got maybe a little hung up on the domain piece. So let's start with the evaluating. F of 1, so when x is 1, y is 9. F of -3, when x is -3, y is 1. F of -8, f of -8, when x is -8, follow that to my graph, and y is -9. And then the last one was the only one that was maybe a little tricky, f of -4. So here's -4. If I go down to the line, I have an open circle, right? But up here, I do have a point when x is -4. So when x is -4, y is 6. F of -4 is 6. I do have a point when x is, or when x is -4. My y value there would be 6. Now, when I give the domain, I need to think about what x values will I have here. So I've got an arrow going down this way, which means I'm going to continue forever back to the negative x's. So that means my starting x would be -infinity. And then because I have a weird thing that happens on the graph here, a lot of us are going to want to break this up, right? Split up our interval or inequality when x is -4. But we only split up the domain if I have an x value that I don't have a point for. Do I have a point when x is -4? Yeah, we do. It's in a weird spot, but I have that point. So x is defined at -4. Unlike our last example, where I did not have a value, I did not have a point when x was 3. So we had to split it up because I couldn't have 3. There was no point at x equals 3. There is a point when x is -4. So I don't need to split this up. We can just keep chugging along. If I'm going to go forever this way, that means I'm going to go up to positive infinity. If you like inequality notation, this would be -infinity is less than x is less than infinity. You don't have to break up your domain here because all of those x values have a y. Let's talk about intercepts. Any x-intercepts on this graph? Do I cross the x-axis? Sure do. Where? Yeah, like -3.5-ish. How about y-intercept? At 7. Good. And then our last one here, write the function that represents this. So for most of it, it's whatever this line is, except at -4. So I'm going to figure out the equation for this line. Got a y-intercept at 7, and then a point at 1, 9. So my slope would be up 2 over 1. So it would be 2x, and then my y-intercept is at 7, plus 7. When I give my piecewise function, this is where I'm going to need to split things up. So for this part, everything from -infinity up to -4, I'm using this line, right? It's the same line. So my first piece would be 2x plus 7 for all x values less than -4. And then when x is equal to -4, my y value is 6. And then when x is bigger than -4, we go back to our line, 2x plus 7. Questions for me? Okay. For homework tonight, bless you, I would like you to work on pages 5 and 6. You are just giving me the domain. You can give me whatever notation you would like. If you want to do intervals, do intervals. If you want to do inequalities, do inequalities.